Today we're going to talk about radiation physics. As you can recall from previous science courses, an atom consists of a central nucleus composed of protons, neutrons, and orbiting electrons. When an unequal number of protons and electrons exist, the atom is unbalanced and it is called an ion. So, what is ionization? It's a process of converting atoms into ions. This is when an electron is removed from the atom and an ion pair results. Electromagnetic energy is pure energy with no mass that travels through space and matter as waves at the speed of light in small energy packets called photons. Electromagnetic radiation is arranged according to their energies in what is called the electromagnetic spectrum, where only high-energy radiation is capable of ionization. So is it non-ionizing or ionizing? Non-ionizing is when the wavelengths are long and have low frequencies, kind of like radio waves or a microwave. Ionizing is when the wavelengths are shorter and have a higher frequency, like gamma rays, cosmic rays, and X-rays. What is an X-ray? Ionizing electromagnetic radiation. X-rays are produced in the dental X-ray machine. Looking at the machine from the outside, we can see the extension arm, the control panel, and the tube head. The extension arm suspends the X-ray tube head and houses electrical wires that go from the control panel to the tube head. The extension arm also allows for movement and positioning of the tube head. The control panel contains an on-off switch with an indicator light, exposure button, and control devices to help regulate the kilovoltage, milliamperage, and the exposure time length of the X-ray beam. The control panel is plugged into an electrical outlet. Electricity is the energy used to make X-rays. A current is the flow of electrons through a conductor in a circuit, or a path of electric current. There are two circuits used in the production of X-rays. We have the low voltage or filament circuit, which uses 3 to 5 volts and regulates flow of the current to the transformer and filament. We have the high voltage circuit that uses 65,000 to 100,000 volts and provides higher voltage required to accelerate the electrons. A transformer is used to either increase or decrease the voltage in an electrical outlet. An X-ray machine uses 3 types of transformers to adjust the circuits. A step-down transformer decreases the 110 to 220 volt current from the outlet down to 3 to 5 volts used in the filament circuit in order to generate electrons. The step-up transformer used to increase incoming voltage from the outlet to 65,000 to 100,000 volts used by the high voltage circuit to accelerate the electrons. And we have the auto transformer also used by the high voltage circuit to correct minor fluctuations in the current. Electricity comes from the wall outlet when the machine is powered on at the control panel. Current is directed to the filament circuit and step-down transformer in the tube head. The transformer reduces the voltage. The filament circuit uses the 3 to 5 volts to heat the tungsten filament in the cathode. Electrons are released as thermionic emission occurs. The electrons stay in an electron cloud until the high voltage circuit is activated. The exposure button is pushed and the high voltage circuit is activated, accelerating the electrons across the tube to the anode, less than half an inch. The molybdenum cup directs the electrons to the tungsten target in the anode. When the electrons strike the tungsten target, their kinetic energy is converted to X-ray energy and heat. Less than 1% of the energy is X-ray and the other 99% is lost as heat which is absorbed by the insulating oil in the tube head. The X-rays produced are emitted in all directions, but because of the lead glass casing of the X-ray tube, a very low number of X-rays can exit through the small unleaded glass window. They then go through the tube head seal and the aluminum discs, removing or filtering the longer wavelength X-rays. The lead collimator restricts the size of the X-ray beam, which then travels down the PID and exits the tube head. In order to understand the interactions of X-rays and matter, you must know the terms primary, secondary, and scatter used to describe X radiation. Primary radiation is the beam that is produced and exits the tube head. Secondary radiation refers to the X radiation that is created when the primary beam comes into contact with any type of matter. It is less penetrating than primary radiation. Scatter radiation is another form of secondary radiation resulting from the ray's deflection from its path upon interacting with the matter. It is deflected in all directions by the patient's tissues, traveling to all parts of the body and all areas of the dental operatory. This type is known to be detrimental to both the patient and the operator.